Hi. So this is the fourth video in Math 83 for factoring. I really recommend you watch videos 1 through 3 before you jump into this one because we're going to use a lot of those aspects in the problems that we're going to do in this section. So let's start out kind of going back to video 3, factoring trinomials where the leading coefficient is 1. So here's an example of a trinomial where the leading coefficient is 1. We don't see any numbers show up in front of the x squared. So whenever we factor this, we're reversing FOIL, and even more than that, it's simpler than just reversing FOIL because we know how our factors are going to have to start to make an x squared. We have to have x times x to start us off with an x squared. So we already had a starting out point, and all we had to do was decide on those two numbers to put into the factors. But that's not always the case. So let's look at an example. Let's say we had to factor this one. Okay, so it's still a trinomial, but this time the leading coefficient isn't 1, it's 3. So we can't just put an x and an x here because that's not going to give us a 3x squared. So one of these has to be a 3x and an x. Okay, well that'll give us the 3x squared. But now we also have to have a negative 5 in our lasts. So these two numbers have to have a product of negative 5 and a sum of negative 2, but not really because that negative 2 comes from outers and inners. So this gets a little bit more complicated than what we had when the leading coefficient is 1. Because now we not only have these two numbers to work out, but we've got this 3 here that's really going to mess things up. So one way that you can do it is just put your firsts here, that gives you your firsts, and then try some of your factors of negative 5 in the other spaces. And what you can do is just try it and then FOIL it and try it and FOIL it until you get the middle term that you need. So here's an example of that. I know that 1 and negative 5 make negative 5. But when I try to FOIL that back, I get negative 15 plus 1. That doesn't make negative 2. So this can't be right. Okay, well how about positive 5 and negative 1? That definitely makes a negative 5, right? But then when we go ahead and FOIL it out, that gives us negative 3x plus 5x. That's not negative 2x, so that can't be right either. Well, why don't we try let's switch the negative and positive signs. Okay, so we're getting there, right? This still makes negative 5, and that gives us a 3x minus 5x, and lo and behold, that's negative 2x. Okay, so this is one way to approach this problem. It's called trial and error. And you really just give yourself two sets of parentheses and just start going. Put in some first terms that give you this first term, and then just start trying out numbers that give you that second term. Sorry, the last term. And then FOIL it over and over and over again until the middle term is correct. It's not my favorite way of doing it. It works, and it may work out on your first try, or as you saw here with even some prime numbers like 3, 2, and 5, it took us 3 tries to get to the correct factorization. So this is something that we would normally go over in class as a method. It's not my favorite because to me it takes too long. It's trial and error, but it's perfectly fine. If you are comfortable with trial and error, just putting things in until they work, that's fine. Perfectly acceptable way to factor. However, we're going to skip over that piece for now, and we're going to go into something called the AC method, which I like because it works the first time every time. It's a lot more technical than trial and error. You have to do a lot more math than trial and error, but it does work the first time every time, and there is no guesswork involved, really. All right, so for the AC method, what we're going to do is we're going to pick out two numbers, just like we did before. We're going to use them for a different purpose. So this time we're going to pick out two numbers whose product is not this last number, but it's going to be the first number times the last number. So this typically is called our A, that's the number in front of x squared, and this constant is usually called our C. This one in the middle is called B, by the way. So that's why it's called the AC method. We're going to find two numbers that have a product that is the same as the first number times the last number. And in this case, that would be 3 times negative 5, so negative 15. Okay, these two numbers also have to have a sum that is the same as the middle coefficient, in this case, -2. So at this point, we're going to treat it just like we did before. Since the product is negative, we know that the two numbers have to have opposite signs. And since the sum is negative, we can kind of cut our work in half by saying, well, that means the bigger number has to be positive. Sorry, negative. Bigger number has to be negative to make the sum negative. So let's look at some factors of -15 that are opposite signs where the bigger number is negative. Okay, so these are two numbers that have opposite signs, so their product is definitely -15. But when we add them together, we don't get -2. So these two are not going to work. Okay, let's try -5 and 3. Certainly when we multiply them together, we get -15, and when we add them together, we get -5. So these are going to be our two numbers. So I'm going to write these up here, -5 and 3. Okay, and I'm going to erase this part. Now, once we found those two numbers back when our leading coefficient was 1, those were the two numbers in our factorization and we were done. That's not how we're going to use them this time. What we're going to do is we're going to use them to break up the middle term. Okay, so this first term is going to stay exactly the same. But instead of writing -2x, we're going to write -5x plus 3x. Okay, we really don't see a purpose in this right now, but in the next step, it'll become really obvious why we want to do this. So just keep in mind when the leading coefficient is not 1, you use your two numbers to break up the middle term. Now, if this thing factors, what we should be able to do is factor by grouping. That was in video 2. So we should be able to take these two and take out a greatest common factor, and these two and take out a greatest common factor, and we should have the same leftovers. So let's look at these two. These both contain one factor of x. And that's it, right? So now we're going to look at what's left over. If we take out a factor of x here, that leaves us with our 3 and one factor of x. And if we take out an x here, that just leaves us with -5. Okay, that wasn't so bad. Now let's look at these two terms. Remember when they don't appear to have anything in common, which these don't, we can always factor out a 1. And whenever we factor out a 1, we just get the same thing in return. So sometimes that's not very useful, but in this case it is. Because now we factor by grouping just like we did in the second video. We have 3x minus 5 in this term, we have a 3x minus 5 in this term. So we can factor out 3x minus 5. And then we write what's left. X plus 1. And if you look back at whenever we did this by trial and error, this is exactly what we got. We may have gotten the factors in a different order, I don't remember, but it doesn't matter. So long as your factors are the same, no matter what order they're in, you factored it correctly. And if you really want to check, again, just FOIL it back out. We should end up exactly where we started. All right, so that's the AC method. Let's do a few more examples. All right, so let's look at, what's our next one? 9x squared plus 66x plus 21. Okay, so now let's look at this and decide where we want to start. Certainly we have a number in front of the x squared that isn't 1, so we're going to have to use the AC method or trial and error. Either way though, you want to look and see if there is any greatest common factor to take out, because if there is, it's going to make what's left over easier to factor. The number of your factors is going to drop, so you don't have to do as much guessing. There aren't as many factors that you're looking to make the sum that you want. So if we look at all these numbers, each one of them contains a factor of 3. And we're left with that. Now, I don't know about you, but if I were using the AC method here, I would have to find factors of whatever 9 times 21 is. I think that's 189 that add to 66. I don't know factors of 189 off the top of my head. That would probably take me a long time. I'd be very frustrated. But if we take out a 3, now we're looking, if we use the AC method, at a product that is 3 times 7, 21, and a sum that's 22. That's a lot easier. Okay, so our product is 3 times 7, the A times the C, which is 21. And our sum is the same as the number in the middle, 22. Okay, so now we need to start looking at factors of 21 that have a sum of 22. Just like we did before, we're not going to bother with opposite sign numbers here because our product is positive. There's no way an opposite or two numbers with opposite signs are going to give us that. Our sum is positive too. So we know these numbers have to both be positive. And lucky for us, the first one we try gives us a sum of 22. So our numbers here are going to be 21 and 1. So now we need to start factoring. And like we talked about before, we took out the greatest common factor of 3, so it needs to stay there. And we're going to use 1 and 21 to break up the middle term. So instead of calling it 22, we're going to call it 1x plus 21x. And we're doing this so that we can factor by grouping. Okay, so let's start factoring by grouping. We're going to want to take these two and these two. We can't forget though that this 3 is still hanging out there out front. So if we look at these two terms, they each contain a factor of x. All right, so if we take away a factor of x here, we have our 3 and an x left over. And if we take out a factor of x from x, what we need to remember here is that that doesn't leave us with nothing. That leaves us with 1. So if you ever take out an entire term, there's always a 1 left. So don't forget that. Don't leave it off. We have our plus sign. And if we look at these two terms, they each contain a 7. And what we hope is that this is what we've got left over. And sure enough, when we divide 21 by 7, we get 3 and our x. And when we divide 7 by 7, same story as here. Whenever we take a 7 out of 7, we are always left with 1. So don't forget that step. If you just leave that 1 off, you don't have the same thing you started with because that term has disappeared. All right, so we still have this 3 out front hanging out because we took it out at the very beginning. But now we can factor out this 3x minus 1. Sorry, 3x plus 1. And in the next set of parentheses, we write what's left when we do that. We have an x and a plus 7. And it's factored. All right, if you had chosen not to factor out the 3, you would just see an extra factor of 3 in one of these factors. And also, if these factors are in the opposite order, like if you got x plus 7 times 3x plus 1, that's okay. Okay, let's look at some more. All right, let's look at 4x squared minus 35x plus 49. Okay, so like in the last one, we see some numbers here, specifically this one, that is not 1. That's disappointing because that means we're going to have to do extra work. But we try for a greatest common factor because these numbers already have several factors in them. I'd rather not multiply 4 by 49 if I don't have to. So we look for greatest common factors. The only factor of 4, or the only factors of 4 are 4, 2, and 1. 1 is not going to be very helpful for us in this case. But 35 does not have a factor of 4 or 2. 49 doesn't have a factor of 4 or 2. So we're kind of out of luck when it comes to greatest common factor. So we're going to have to multiply 4 and 49. So the product of the numbers we're looking for is going to be whatever 4 times 49 is, and we'll talk about it. And the sum has to be negative 35. All right, so 4 times 49 is going to be 196. Pretty sure. Check it in your calculator. So now we've got to think of factors of 196. This is not going to be very fun. But one thing we can do to help us though is that this is positive, meaning that both of the numbers have to have the same sign, and the sum is negative. So if the numbers have to have the same sign and we add them together to get a negative number, we're looking for 2 negative numbers here. All right, so let's start. Let's start with the obvious one. Negative 196 and negative 1. which is obviously wrong. We add these together, there's no way we are getting negative 35. Okay, let's try negative 2. And if you divide this by 2, I believe you get 98. Yes. Add these together, no way. There's no way that's getting us negative 35. So no. All right, we can tell if it's divisible by 3 if we add these digits and the digits give us a sum divisible by 3, but if we do that, 16. So that's not divisible by 3. We're not going to worry about even trying 3. Okay, let's try 4. Well, we already know, right? 4 times 49 is negative 190, or is 196. So what we're doing here is 49. Still not a negative 35. So there's a no. We know it can't be divisible by 5 because the number doesn't end in 5 or 0. Can't be divisible by 6 because it's not divisible by 3. Let's try 7. Okay, well, whenever we divide 196 by 7, we get 28. If we add negative 7 and negative 28, what do we get? Bingo. Negative 35. So those are going to be our two numbers that we use to break up negative 35. So I'm going to just write them up here to save us some space. But it was a little bit of a guessing game here, but you can do it systematically. We didn't check both positives or both negatives because we knew that couldn't be the case. So using that little bit of knowledge can save you some time. So just like before, we're going to use these two numbers to rewrite negative 35 and hope that we can factor this by grouping. So let's look at these two numbers, or these two terms. Both contain a factor of 4, that's good, and both contain a factor of x. So we can factor out a 4x. And what are we left with? Well, it only leaves us with our one factor of x there. And here, just with a negative 7 or a minus 7. Okay, so now let's think strategically here. Remember when we're factoring by grouping, we want to factor something up that leaves us with the same leftovers. So we want to be left with an x minus 7. If we just factor out the obvious greatest common factor here, which is 7, that would leave us with negative x plus 7. So we're not going to want to factor out a 7 here. We're going to want to factor out a negative 7. And you'll see why. If you factor out a negative 7 from here, that leaves us with x, which matches right here. And if we factor out a negative 7 from 49, we get negative 7, which matches here. All right, so if you notice that these leftovers match with everything but the sign, like one is positive and the other is negative, try taking out the negative of the greatest common factor that you saw. You're always allowed to do that too. So if 7 doesn't do it for you, try taking out a negative 7. And sure enough, they match. So we have x minus 7 that's common and a 4x minus 7 that's left over. And once again, whenever we FOIL this out, whenever we multiply it out, we should end up exactly where we started. And again, if these are mixed up, depending on the order that you put these numbers in, your factors could end up in the opposite order. Totally fine. So long as they are the same factors, you're fine. All right, let's try one more because this video is getting too long. But we'll try one more. I want to make sure we see all the possibilities here. So let's look at 15x squared minus 27x minus 6. Okay, so again, we see this number in front of x squared, which means we can't just put x and x in our factors. We're going to have to factor by grouping. We have to use the AC method. But before we start, let's try a greatest common factor, because we know even though that won't complete the problem, it might make what's left over a little bit easier to factor. So we see 15, 27, and 6. Start running through the factors of 15, I'm not going to go into all of them. 5, nope. 3 is going to go into all of these numbers. So our greatest common factor is 3. Let's go ahead and factor that out. Okay, so as you can see, your numbers got smaller. The factors you're having to try to work with just got a lot easier. The factors just went down a lot. So now we're still going to have to use the AC method. So the product of the two numbers we're looking for is 5 times -2, or -10. And the sum is -9, that number in the middle. So we're looking for two factors of -10, so they have to be opposite signs, that add to -9. So we know the bigger number has to be negative. So let's try with the obvious one, -10 and 1. And look, that one works. Okay, well that was pretty quick. So we're going to use these two numbers to rewrite that middle term. So instead of -9x, we're going to write -10x plus 1x, which you are free to leave off if you want. And then we have our -2. We can't forget to keep writing that 3. So now let's factor by grouping. Each one of these contains a factor of 5 and a factor of x. So we can take out a 5x. What's left over? One of these x's and a 2, -2. Okay, now we look at these two. Well, they don't have any obvious factors in common, but any time there's nothing to take out, there's always a 1 to take out. And if we take out a 1, sure enough, we are left with x minus 2. Just like we hoped, because it matches right here. Can't forget to keep writing that 3. But now we can factor out this x minus 2. And in parentheses, we write what's left over. 5x plus 1. So again, these might be flip-flopped. The factors might be written in a different order. No big deal. If you chose to just work with these numbers here, you might see a 3x minus 6 or maybe a 15x plus 3 somewhere. Again, they're all exactly the same. Multiply them out, you should end up what you started with.